So to raise the temperature of water from 20 degrees to 100 degrees is going to require an amount of heat given by Q1 equals mc delta T, where m is the mass of the water, C is the specific heat of water, delta T is the change in temperature in water in Kelvin. So this is going to give us, if we have 1 kilogram of water, C we can look up in the table, and we find out that it's 4190. Some books might give it, or some searches will give you 4186. I will be giving you that on a quiz or a test, so don't worry about memorizing it. So let's use 4190, and then the change in temperature is going to be 100 minus 20. I'll change this to Kelvin because, again, a change in temperature is okay in either degrees or Celsius or Kelvin. So this will give us an amount of heat equal to 3.35 times 10 to the 5th joule. This is for heating the water. And now for boiling the water, we're going to have a phase change. And the phase change will require an amount of heat given by the mass of the water times the latent heat of vaporization for water. And this, again, we would read off of the table. So we have 0.25 of the 1 kilogram is being boiled. The latent heat of vaporization for water is 2.256 times 10 to the 6th joule per kilogram. So this gives us 5.64 10 to the 5th joule. So the total energy is going to equal the sum of Q1 plus Q2, which is 8.99 times 10 to the 5th joule. This 8.99 is 30% of the total heat of combustion. So total heat of combustion is going to equal 8.99 times 10 to the 5th joule over 0.3, which is 30%, which is the same as about 3.00 times 10 to the 6th joules. And now we can look up what is the combustion heat, or the amount of heat released from burning 1 gram of gasoline. And if we look that up, 1 gram of gasoline will release 46,000 joules when it's burned. So if we want to find the weight, we can say that if we have an amount of energy of 3 times 10 to the 6 joules, and we multiply that by 46,000 joules per gram, this will give us about 65 grams of gasoline. Now, if we wanted to change to from gasoline to liters, we can find out that this is about 0.09 liter. Keep in mind that 1 gram is about 1 milliliter. mistaken. But I'm sure of